Since the early 16,000s, telescopes have been used by stargazers or astronomers. It is a tool that they use to see faraway objects. It provides a means of collecting and analyzing celestial objects, even those in the far reaches of the universe. But if you ever wondered about the science behind the telescope, the magic that could conjure a perfectly crisp image inside a tiny tube when all our eyes can see is a tiny blur of image, then this video is just for you. In this video, we will be explaining to you the science or magic behind the telescope. Before getting to that topic, we must first answer this question. Why is there a limit to what a human eye could see? When something is farther out, it is smaller due to what we call perspective. It also slowly gets darker, eventually getting to the point when there's not just enough light bouncing off that object and reaching our own eyes. To make it short, in order for us to see things farther away, the first things we need is gathering much light as possible, and second, increasing the apparent size of the distant object. One way of doing that is using lenses, a piece of glass that refracts lights that bends it as it passes through air into denser glass.
The first telescope was constructed in the year 1608 by Dutch spectacle maker Hans Lippershey. It consists of two lenses aligned with each other capable of magnifying objects up to 3 times its original size. A telescope magnifies an image by focusing the light entering from the optic lens, where it converges and enters into the concave lens where the light ray creates an image. This image is what we see when we look into a telescope. In reflector telescopes, the light coming from a star goes inside the optical tube and is first reflected on the primary mirror located at the back. The primary mirror is the most important part of the reflector. It has to collect and make the light beams converge toward the eyepiece holder, the element where we put our eyes into. Here, it is necessary to find a way to make the light beams travel in a direction going out of the tube. Therefore, a secondary mirror is installed next to the front aperture of the telescope, enabling beams to be deviated on the side of the telescope and so to observe an image. The asset of a reflector is the very large size of its primary mirror. The bigger the mirror is, the brighter the object appears in the eyepiece. However, a big mirror could quickly emphasize the optical aberration of the telescope. Theoretically, getting a perfect round dot of a star requires having a Newtonian reflector made with hyperbolic primary mirror. In fact, such a mirror is relatively expensive and telescope manufacturers choose rather a parabolic mirror instead, which is far simpler to build. However, a parabolic mirror faces a defect where coma aberration deforms and elongates the stars around the field of view.